Hello everyone, welcome to this mini project video presentation. Today me and my partner Adli Rahman is going to start and present for this ELE355. So my student code is 2023486498 and my partner is 2023675462. Before we start going through this presentation, I would like to go for a brief overview on the table of content, which is the introduction, problem statement, objective, block system, datasheet, calculation, proposed circuit, PCB design, simulation, and final budget. So we know that water is essential in resource in daily life, playing a critical role in domestic agriculture and industrial application. Therefore, to ensure a steady and efficient supply, water tanks are commonly used as storage system. However, managing the water level inside these tanks remains a challenge in many conventional setups. So for our problem statement for this mini project, water tank storage is a storage solution for water used in many domestic agriculture and industrial purposes. Therefore, to control the water level in the tank, most systems use ineffective mechanical methods. A simple and applicable system to control the water levels in the tank can be implemented by using electronic base such as a transistor circuit. For this mini project, we propose two solutions. Implement a water level control system using electronic components such as transistors, resistors, and relays. And second, use float rods or level probes as input triggers for different water levels. In this mini project, we have three objectives: to design an electronic water level system, circuit design. Second, to automate the system by developing a switching control system circuit. And lastly, to simulate and validate our proposed circuit design using EDA tools. So for the next slide, I would like to give it to Adli Rahman.
Thank you, Axel. So now I would like to present on a block system. The system monitors the water level using a float rod. Switches at a different height depends on the water level. It will send signal to the transistor base circuit that activate the LED, the buzzer, a relay to indicate the level and control the water valve automatically. So this is the block system. In the water monitor tank, it have water level sensor, which is the float rod. The float rod will be placed at a different height depends on the water level. So 0 to 50%, it will trigger the green LED. 50 to 75%, it will trigger the yellow LED. 75 to 90%, it will trigger the red LED. At 90%, it will trigger the red LED buzzer, and it will also trigger the relay, which will close the valve automatically. For the output control mechanism, the LEDs to indicate the levels, buzzer for overflow warning, relay to close the valve automatically. So this is the data sheet. We choose the transistor NPN switching transistor of 2N222 as our main transistor. This is the proposed circuit. So the specification, 2N222 VCC 15 volt common emitter configuration. Why we choose common emitter? So first of all, it acts as a switch, ideal for on and off control of LEDs, buzzer and relay based on sensor input. Second, it is high gain, provides sufficient gain to activate higher current loads like relay or buzzer. And the third one is simple and cost effective. It's only require a transistor and base resistor. So this is the circuit in Proteus. In the simulation, the lamp represent the valve, the switch represent the water level, the percentage of the water level. This is the PCB design in Proteus. This is the front view and this is the back view of the PCB. So now let us dive into the calculation part. So from the datasheet, we assume IC equal to 10 milliampere, the beta is 75, the VCE is 10 volt. So the base current is equal to 133.33 microampere. For 0 to 50%, the green LED part, at best we use KVL, negative VCC plus IBRB plus VBE, and then from that we get the resistor base current at 107.25 kilo ohm. But then we change it into E12 series. At collector, the RC is 250, E12 series is 270 ohm. At 50 to 75%, which is the yellow LED, at best, the best resistor is 107.25 kilo ohm, and E12 series it will become 100k kilo ohm. And for RC is 300 ohm, E12 series 330 ohm. For the 75 to 90% red LED, best current, best resistor is 100 kilo ohm, and for the RC is 330 ohm. And for the buzzer, the best resistor is 92.25 kilo ohm, and then E12 it will become 100 kilo ohm. Now let us dive into the simulation part in Proteus. So now I would like to present on our proposed circuit in Proteus. Let us do the simulation for this circuit. So once the water moves to 0 to 50%, it will light up the green LED, and once the water moves to 50 to 75%, the yellow LED will light up, and then once the water continues to rise up to 75 to 90%, the red LED will be triggered. Okay, what will happen once the water reach almost overflow of the water level monitoring tank? So once the water level reach almost 95% of the volume of the water monitoring tank, the red LED will light up and the relay will also be turned on. So the relay will turn on and it will close the valve. So the lamp represents the valve, and the buzzer will also make sound.
Alright, thank you for the last presentation, Adli. I would like to go through the financial budget now. So we have 5 components: LEDs, resistors, our chosen transistor which is 2N2222, relay, and lastly float sensor. So in total of all the components, it is Rm 24 and 60 cent, which we found out in the online shopping, which is Shopee. For the conclusion of this mini project, that all our project objectives were successfully achieved and an electronic water level system was effectively designed, fulfilling the first objective. Next, the system was then automated through the through the development of switching control circuit, meeting the second objective. And lastly, the proposed circuit design was validated using EDA tools, which is Proteus, confirming its functionality and completing the third objective. That is all from us. Thank you.